We began by dimensioning out the pieces of our cooler on polypropylene sheets. The pieces were then cut out initially by the band and jigsaws. After our initial cuts, we determined that the metal shears made more precise cuts. These pieces were then welded together using a plastic welder and polypropylene rods. The pieces were held in place using a 90-degree corner and clamps. This helped align the pieces to make the box square. We used a thermoelectric unit to cool the cooler. A thermoelectric unit gets cold on one side and hot on the other. A heat sink and fan were attached to the hot side of the unit to dispense the heat away from the cooler. The thermoelectric unit was powered by a 12-volt battery. A solar panel was mounted to the top of the cooler and is used to charge the battery. A hole was drilled through the lid to allow the wires from the solar panel to be hooked up to the battery without hassle. The rope handles were attached to each side of the cooler. The rope was wound around itself to allow for a comfortable grip. Testing was conducted on the cooler. First, time to reach room temperature from 50 degrees C was tested. This test gave a good estimate of the quality of the insulation. 5 specimens of polypropylene were tested by the 3-point bend method. 1 specimen was the control, 1 was exposed to UV for 24 hours, 1 was exposed to water for 24 hours, 1 was placed in the fridge for an hour, and the last one was placed in the oven for half an hour. A fish scale was used to test the force required to open the lid. A drop test was conducted on the cooler. This consisted of dropping the cooler down the stairs multiple times. For the final cooler, the insulation was changed due to the heating of the inner chamber. The final cooler also contained a recessed lid to help better seal the inner chamber.
This thermocouple device measures the temperature differential from the interior of the cooler. As you can see from the beginning, the temperature began at 61.5, and for the duration will drop to 60.7 for the next several seconds. This gives a clue to the functionality of our cooler being present. As you can see, the fabric and the airflow shown in this video is dispersing the heat from the opposite side of the thermoelectric cooler.